Hello, families, and welcome to the October edition of the 5th grade math newsletter. In this edition, we'll be diving into Unit 1, specifically into multi-digit multiplication. One way that you can support your child at home is by understanding and helping them to understand the bridge or the connection between partial products and the standard algorithm. On the left side, you see partial products. Students have been using this method since 4th grade to help them solve multi-digit multiplication problems. What it asks students to do is take each of the factors, in this case 43 and 17 are our factors, and break them apart into place value. In doing this, students have a better conceptual understanding of the values they're multiplying together and not simply just the digits. On the right side, you see the standard algorithm. This is the traditional method that many of us were probably taught in school. It also has a foundation in place value, but it's not as clearly seen. So having students understand the bridge between the two is important to their success. Let's try a problem together so we can understand the connection. 34 times 21. With partial products, the first thing we would do is expand each factor into place value. 30 plus 4 times 20 plus 1. The next thing we need to do is multiply each place value in one factor by each place value in the other factor. We'll start with our ones. 1 times 4 is 4. Keeping with the 1 times 30, the other place value, the tens in the other factor, equals 30. I've used up 1, so now I need to move over to my tens, which is 20. 20 times 4 equals 80. And now my tens times tens, 20 times 30 equals 600. For the last two problems, we've taught students to look at the basic facts within a problem. 20 times 4 might be difficult for a student, but they can look at the basic fact 2 times 4 and know that's 8. They would then say to themselves, 2 times 4 is 8, but this is 2 tens times 4, so my answer has to be 8 tens. Same thing with 20 times 30. The basic fact is 2 times 3. 2 times 3 is 6, but this is 2 tens times 3 tens, and 10 times 10 is 100. So my answer isn't 6, it's 600. When I add up all those products, I get an answer of 714. So let's go ahead and bridge that over to the standard algorithm. We would line up the factors just like this, and then we do the same thing. We ask the students to do 1 times 4, that's 4. 1 times 3 is 3. So you can see in just following the traditional procedure, we aren't really talking about value. We're just talking about the digits. The connection shows us that that 3 isn't just a 3, it's 30. So I get 34 when I multiply the 1 by the other factor. On the left side under partial products, you can see that my top two products, 4 and 30, equal 34. Students then are usually taught to just place a 0 and move over. The reasoning behind that is because we're done with our ones and we're moving over to our tens. When I move over, I have to put a 0 as a placeholder. The reasoning behind this is if I'm multiplying by multiples of 10, I won't have any ones. So the 0 there just reminds me to move over and I won't have any ones. The next thing I need to do is move over to 2. 2 times 4 is 8, and 2 times 3 is 6. But if we're talking about place value, that's 20. So it's really 20 times 4, which is 80, and 20 times 30, which is 600. This is why we get 680. The next thing I would do is add those up, and I can see I would get the same result. It equals 714. So again, if you'd like to help your child at home understand the standard algorithm of multiplication, which is the end goal for fifth grade students. Looking at place value, which we can see in partial products, and connecting that to the standard algorithm is one way to support their learning.